Hi guys, here's the exam question of the equilibrium forces. Let's cut the chase. Now it says the structure below shows a system that is in a state of equilibrium. The strings with forces T1, T2 and T3 join at point O. Here's T2, T3, T1 joined at point O. The mass of the block is suspended from T3 is 240.8, which is the weight of this mass. It's the mass of this object, and so that's the weight. Okay. Now, guys, if you're looking there, there's a point of interest there, which is the point where the force are acting at that point. There's a tension force and there's a gravitational force. That's a gravitational force. If you were watching my previous video, you understand what do I mean. So, guys, yeah, there are those forces there. Let me draw the free body diagram. It's not asked here in the question. So the free body diagram there, it will be T2 there, and then it will be T3, T1, sorry, and then the gravitational force there, which is T3. The gravitational force there is equal to T3. T3 is the tension, but that tension is pulled by the weight of that mass. Now, let's answer question 1, 3.1. What does the word equilibrium tells you acting at point O? It means that the F net, the net force is equal to 0 and the acceleration of point O is equal to 0. So point O is not what? Moving, is stationary, is not moving. Now 3.2, it says calculate the weight of the block. The weight of the block, we're given the mass there. So while we're given the mass, the weight there is Fg equal to mg, right? Then the mass there, it's 204,082. We multiply by 9.8, which is g. The answer there, it's going to be what? 2000 newtons. So the weight there, which is T3, is equal to 2000 newtons. Now 3.3, it says draw the labeled closed vector diagram showing forces acting at point O, indicate all the angles. Now 3.3, guys, there I've already shown you how to draw the vector diagram in the previous videos. Check the previous videos. So here I'm going to start with in this case, I'm going to start with the gravitational force, which is T3. I'm going to start with T3, which is the gravitational force. And, okay, before, let me start with, let me start with T2, T1. If I draw T1 there, T1 like that, and then followed by the gravitational force, which is T3, and then there will be T2 there, a T2, sorry for that, and then this angle will be what? 70, and then this will be 90, and this angle will say maybe it's a theta there. Oh, okay, we can't put theta there. So if it's this, it's 90, it's 160. So this one will be 20 degrees. That will be 20 degrees. Alternatively, we can draw it like this. We'll start with the gravitational force, which is T3, and then followed by T1, and then there will be that tension, which is T2 there. So we'll have 90 there, and then this will be 20, and this will be 70. Right? So how do I mean this will be 70. So if you rotate this one, oh no. Okay. Okay, let me use this one. Let me use this one. If you rotate this one, like this, oh my god. Okay, let's leave the rotation. Okay, let me try to do it here. Yeah, if you rotate this one, do you see? Is the same as this one. Do you see? It's just the rotation. So I drew it like this, which is the same vector diagram, and I've shown all the forces there. Now let's do 3.4, which is the last question. 3.4, it says determine by means of calculation the magnitude of T1 and T2 and T3. It's quite a lengthy exercise. It's 5 marks. So what we're going to do there, we're going to use the trig ratios there. We're going to use the trig ratio. We're going to use let's use this one. Let's use this one. So I want it's T. I have this one, guys. That's one thing that you need to remember. I have 2000 newtons for T3. So I'll use what I have. I'll say opposite over adjacent. So I'll use 10, which is tau. So it's 1070 degrees is equal to what is my opposite? It's T3. T3 divided by T1, which is my opposite over adjacent. So let me substitute there. What is my T3? It's 2000 divided by T1. So that means now I'm going to get T1 there. So you have 1070 degrees T1 equal to 2000 when you cross multiply there. When you cross multiply there, and then you divide by 1070 both sides. 1070 both sides. So your T1 there, the force, it should be 727.94 newtons, right? Alternatively, what you can do there, you can use 1020 using this one. It will be opposite over adjacent. So you have 1020 degrees using that one. It will be T1 over T3. So that simply means that what is your T1? You don't have T1, but you have T3, which is 2000. T3, remember, T3 is the gravitational force, and then you cross multiply there. So you have T1 is equal to 1020 degrees times 2000. So it will yield or it will produce the same answer. The answer, it will be 727.94 newtons. So we're done with T1, right? We're done with T1. Now let's look at T2. We do not have T2. Let me push this up a bit. Okay, let's look at T2 now. T2, let me use another color. T2, now that we have T1 and T2, so we can use another trig ratio here, which is sine. Let's look at this one. So what if we say opposite over hypotenuse, right? So it will be sine 20 degrees, which is opposite now. Opposite of sine 20 there, it's T1. Then our hypotenuse is T2. Remember, we have T1. So sine 20 degrees is equal to T1. Our T1 is 727.94 divide by T2. So we want T2, and then we cross multiply there. So we'll have T2 is equal to 727.94 divided by sine 20. So the answer of that, if you punch that in the calculator, it will be 2128.33 newtons. Alternatively, what you can use there, you can use sine 70. You can say sine 70, which is opposite. Okay, it's opposite over hypotenuse. So basically there the alternative, so it will be sine 70 degrees. The opposite is going to be what? T3. T3 over T2. So sine 70, a T3 is 2000 and a T2 is the one that we're looking for. So when you cross multiply that, you will have T2 that is the same answer, which is 2128.33 newtons. And that's it, guys. I hope you understand.